is the topic of today's lesson, among other things. Push pause, get your calculator. You can't do a lot of these steps, or a lot of these problems, I should say, without a calculator. Super helpful. And you're going to learn more keys. So first thing about a factorial is it's a super excited number. 3, 10. See, numbers with exclamation points. These are factorials. Okay, in all seriousness. A factorial is a number and you multiply by every whole number below till you get to 1. What's that mean? Here's what you do. 3 factorial is 3 times 2 times 1. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. On your calculator, a couple ways you can get there. Math, arrow over to PROB, which stands for probability. PROB stands for probability, and if you'll notice, it is number 4. So what you need to do is 10, math, PROB, and then either arrow down to the 4 or just push number 4. And let me do that. So it says 10, math, probability, 4. And so on your screen it says 10 exclamation point. And that would be I don't even know what that is. 3,628,800. Commas are a must. Commas are a must. 3,628,800. There's also a shortcut. Alpha. I think it's alpha window. Nope. Sorry. Alpha. Quit. Alpha window? It is. Alpha window, depending on which calculator you have. Some calculators have the shortcut. Alpha window number 9. They both get you to the same place. Regardless if you use math probability or if you use alpha window, you still have to hit the number that you want the factorial of. You have to enter that first. Okay, we can do some multiplication and some division with factorials. Adding and subtracting factorials, sure, but it's kind of pointless. Okay, so let's look at something like 8 factorial over 4 factorial. You cannot reduce this. This does not become 2 factorial. Okay, first of all, you can't just cross off the factorial symbols. That's about as voodoo as it gets. No. It does not equal 2 factorial. So let's write it out. First of all, yes, you can just do it flat out on your calculator, but you need to know how to write it out because the process is more important than pushing buttons on your calculator, even though that is the easy way to go. I'm just going to stop there. 8 factorial is 8 times 7 times 6 times 5 times 4, 3, 2, 1. 4 factorial, if I just leave this, 4 factorial over 4 factorial is okay. Anything divided by itself is 1, except for 0, and that's a whole other story that you'll talk about in calculus. Now you can reduce. So you get, 56 times 30. You're probably ahead of me. How about clear 56 times 30? 1,680. Notice that it's not 8 factorial. It's just flat out 8 times 7 times 6 times 5. So that would be 1,680. Okay, what if I give you variables? So let's start with n factorial. We use n in probability. Wait, Miss Babiak, this isn't probability, but it's going to take us there in the next couple of lessons. N factorial. Okay, so n factorial. So what is one number below n? N minus 1. What is a number below n minus 1? Yeah, n minus 2. N minus 3. And so forth until you get to 1. You're always going to end up at 1. Okay, so let's do some simplification with variable factorials. Factorial is just a number times every whole number below it until you get to 1. All right, so let's look at something like n plus 1 factorial over n minus 2 factorial. Okay, so let's wrap our brain around something. I did 8 factorial over 4 factorial, and I started with 8, which is the higher number. Agreed? 8's higher than 4? So I started with 8, which is the larger number, and I simplified it down until I got to 4 factorial. And I stopped at 4 factorial because that was the denominator, and then I could reduce and say 4 factorial over 4 factorial is 1. We're going to do the same thing here. Regardless of what n is, let's say n is 10. 10 plus 1 is certainly greater than 10 minus 2. Let's say n is 50. 50 plus 1 is certainly greater than 50 minus 1, or 50 minus 2. So no matter what n is, n plus 1 is the larger. So I'm going to start with the n plus 1. What comes after n plus 1, like on a number line? What is the number 1 less than n plus 1? N. And the number 1 less than n is n minus 1. And the number 1 less than n minus 1 is n minus 2. And I'm going to stop because my denominator is n minus 2. N plus 1. So if it was like 10, let's say n was 10. That would be 11, 10, 9, 8. Well, ba-boom, ba-boom. N minus 2 factorial over n minus 2 factorial is 1. So you are left with n times the quantity n plus 1 times the quantity n minus 1. Do you need to multiply that out? No. Is it wrong if you do? No. But I've said this before, why do more work than you have to? One more chance to make a careless mistake. Okay, so that's factorials, and we're going to use those in probability. All right, so this is 11.8. 12.1 and 12.2 kind of go to, well, they all go together, so I'm not going to do a ton of examples. What we really need to review for probability are dice and cards. Vegas, baby, gambling, all about dice and cards. All about dice and cards, except for roulette, which is about a little wheel that spins and nobody ever wins. They suck you in because you think, oh, maybe if I spin the wheel one more time, I'll win. And then you don't. I have all kinds of stories I could tell you, but I won't. Okay, dice and cards. All right, fair dice. Fair dice means they're not weighted, which means your chance of rolling a 1 is exactly the same as your chance of rolling a 5, which is the same as your chances of rolling a 6, etc. Weighted dice, which are cheating, means the dice is weighted, so to speak, more towards one number over another. We're always going to be talking about fair dice. Okay. Generally, we're going to roll 2 dice in our experiments. Okay, so I'm only going to start this. It's on one of the pages in the book. I don't know which one. You can find it. One, two, three, four, five, six, etc., etc., etc. I'm going to fill this in with the potential sum. So if I roll a 1 and a 1, also known as snake eyes, the sum is 2. If I roll a 1 and a 2, I'm going to get 3, or if I roll a 2 and a 1. So there are 2 ways you can get a sum of 3. One die can be 1, the other die can be a 2, or a 2 and a 1, yet you yield the same sum. So it can happen 2 ways. So there's this chart, again, it's in section 12.1, I think, I don't know where it is, you'll find it, where you can figure out the sums. There are 36 total sums. It's going to come up a lot. There are 36 total possible sums. Cards. We're going to use, I'm going to be using card examples pretty much exclusively throughout the remainder of this chapter. There are 52 cards in a deck. In a fair deck, there are 52 cards. There are 4, and they're called suits. And the suits are clubs, which are black. There are spades, which are black. There are hearts, which are red. And there are diamonds, which are also red. Okay? 4 suits. 2 black suits, clubs and spades. 2 red suits, hearts and diamonds. If there are 52 cards, 4 suits, there are 13 cards per suit. Okay? 13 per suit. We're not going to talk about jokers. Forget the jokers. All right. There are 3 cards that we call face cards. And if you've ever seen a deck of cards, these are called face cards because there actually is a face on the card. So the face cards are Jack, Queen, and King. There are 4 of each card in a deck. And if you already know this, great, but some people aren't familiar with cards because you guys all play video games and those don't involve cards, and so you don't play old-fashioned games anymore. Hopefully you're playing games with your family and your friends. 4 jacks, 4 queens, 4 kings. So there are 4 of each. Jack of hearts, the jack of diamonds, the jack of clubs, the jack of spades, and on and on and on. Okay, then there's the ace. The ace is special. There are 4 aces. An ace is not a face card, but it's not considered a numerical card either. A 2 is a numerical card. A 5 is a numerical card. An ace is special. All right? An ace is special. So make sure you know this. Okay. All right. So if you need to, you can rewind or pause and get that all written down. Vocabulary. An experiment is the act of drawing the card. It is the act of rolling the dice or tossing a coin. So here we go. This is 12.1, 12.2, I don't know what it is. It doesn't really matter. We're going to play games. If we were in class, we'd play games. I want to know that you're going to toss 2 coins. Okay, I'm going to toss 2 coins. I want to know the probability that I get 2 heads. Probability that I get 2 heads. So, probability of some event is the number of ways the event can happen. Number of ways the event can happen over the total number of ways for the event. The event can happen. the total number of ways to, you know, toss the coin, draw the card. There is a specific word for the denominator and I can't think of it off the top of my head. So I'll do a couple examples. I'm sorry, I can't think of what this is called. The number of ways the event can happen. Here we go. The probability that I toss the coin and I get ahead is 1/2. There's one way you can get ahead on a coin over 2 total ways that the coin can be tossed. You get a tail or a head. So probably that I draw 1 head is 1/2. This is if I do 1 coin. 2 coins. The first coin could be a head. Great. So if I want 2 heads, there's a 1 in 2 chance, 50% chance I'm going to get a head the first time. And then when I toss the second coin, that's also going to be a 50-50 chance that I toss and get a head, for a total of 1/4 or 25%. I'm just going to draw this out. I could get 2 heads when I toss the coin, which is what I want. But the first toss could be a head, the second toss could be a tail. The first toss could be a tail, the second toss could be a head. You can see why this is going to be very tedious when you do more than 1 coin or 2 coins. Or both could be tails. Here you go. Both heads, 1 in 4 chance. A 1 in 4 chance. Okay. I'm still here. You can't see me, but I hope you can hear me. If you have your book, page 639, if you have your book. Nope, I lied. Page 635. 639 is tomorrow's lesson, or whatever lesson it is. Oh, I just found it. Remember, I was like, I can't remember what the denominator was supposed to say. It's on page 634. Number of outcomes in the sample space. The sample space is the total number of ways things can happen. Total number of ways. Or total number of outcomes. There we go. Okay, sorry about that. Okay. Probability, we're going to do cards now, okay? We're going to do cards and we're going to draw 1 card. The probability that you draw an ace. Okay, how many aces are there? 4. How many total ways can you draw the card? 52. Always reduce. You have a 1 in 13 chance of drawing an ace. Let's figure out what that is percentage-wise. Percentage-wise, it is about 7.7%. Exactly is where things get messed up. Okay, let's draw 2 cards this time. Okay, 2 cards, blackjack, 21. It's the most common, or the most famous, I should say, 2-card game, blackjack. Here we go. I want to know what is the probability that you draw 2 aces. Okay, it's the second fraction that matters. It's the second fraction that matters. How many ways can you draw an ace? 4 out of 52. 4 out of 52 times, and I want to draw an ace and an ace. That is multiplication. Okay, so here's the kicker. If I want to draw 2 aces, great, I've drawn an ace. How many aces are left in the deck? Not 4, 3. I've drawn a card. Okay, I've drawn a card. So how many cards are left in the deck? How many cards are left in the sample space? 51. Okay, 12 divided by 52 times 51. You should be doing the problem with me. 1 over 221. Which is 0.45%, I believe. I've done that right. I hope so. You're probably yelling at me through the camera right now. Yeah, 0.45%. Okay. Let's do the probability that I draw. Here we go. The Jack of Hearts. And how about the King of Spades? How many Jack of Hearts are there? 1. There is 1 Jack of Hearts. So I've got a 1 in 52 chance of drawing the Jack of Hearts. The King of Spades. So if I'm going to draw the King of Spades, how many King of Spades are there? 1 out of 51 cards that are left in the deck. This is why getting blackjack is very hard. 1 divided by 52 times 51. One out of 2,652. Okay, so here's the kicker. I say it a lot, don't I? Here's the kicker. 1 over 2,652. On my calculator, that says 3.77073965 E negative 4. There's no such thing as E negative 4. It represents scientific notation. So this is 3.7707 blah blah times 10 to the negative 4. Okay, you multiply that by 100 to get the percent. So this is here, here, okay? To get the percent, I multiply by 100. This is 0.04%. You don't have even a percent chance of drawing the Jack of Hearts and the King of Spades. Is it possible? Well, of course it's possible, but chances are it's not going to happen. I wouldn't bet my money on it. Okay, so that was a very long, drawn-out lesson, on factorials and the beginning of probability. The next 2 lessons are much more fun about ways that you can make a pizza and ways to win the lottery, which is not going to happen. Don't get used to it. But that's that. All right, 2 more lessons left, you guys. Bye.